Now listen, going to show you the script. Do you have any question from the last lecture? Because still having time to discuss about that. We have completed the RL circuit, uh, and last moment I told you about the complete response of RL circuit. So can you please open your class note, and if you have any question regarding the RL circuit, you can ask me, or if any other type of problem, you can also discuss with me now. You have any question, any of you? You can ask me if you have any question. Hmm? You just look at the class note, last lecture. I think we have gone through lecture. Okay. Um, on the lecture, you can find some sort of online lecture response. You can find it from there. RL, if you see this problem, this is one of the problem given from the final exam question paper. So if you can solve this problem, any type of problem from RL circuit, you are capable to answer. Uh, this is I already uploaded in the BUX, but I'm not going to solve this problem particularly, but a very similar type of problem I'll solve today. And after that, we will go for the next topic, which is RC circuit. But before RC circuit, this RL circuit, we are going to solve first. RL complete response thing, last class I have shown. Remember these sort of things, R and L. That means if you close the switch at time t equal to 0, then a voltage source is imposed on the RL circuit, applied on the RL circuit. In that case, a current will flow IL, and that current I have shown you to calculate it in that way, IN plus IF, natural plus forced. And from the natural, we already know, close our I and can write it, I naught e to the power minus R by LT. And RF for t tends to infinity, all of you have seen, it was E by R. This is what, and initial condition at time t equal to 0, IL, there is no IL current, so IL is 0. So at t equal to 0, we substitute the value of 0, and from there A plus E by R. And from there A we find minus E by R. And that's IL is given you here, E by R. Finally, we got like that, E minus e to the power minus R by LT. This is what the force response IL. Last class, this is what we have seen. And if we plot it, we have plotted like this. It start from 0, E by R, the final value, and it start from 0, it exponentially rise like that. This is the curve IL equation for this one. You can remember last class we have gone up to this, 1 minus e to the power minus R by LT. Also the voltage curve we have seen, which is VL. It just straight away you write LDIL by dt, and IL value you straight away substitute here, and you got what? I think E to the power minus R by L. After substitution, all these things, you get something like that. and this is VLT. Up to this we have done. Now, based on this knowledge, today we are going to solve a example. Just now I show you similar to that. And after that, we are going to start our next class on RC circuit response. That is today's class. We are going to go after finishing this problem on the complete response problem. This is complete response problem. RL complete response problem. Now that's today we are going to do at when the class is started 9:30. Okay, now it is almost 9:30. Do you know? Okay. Hey, how was your city 3? Everything is okay with you? City 3? Hey, could you answer city 3 properly? Someone should talk. Akib, how about you?
Yes, sir.
How was your city 3?
It was average.
Average. Jihad? Jihad?
No, sir, it was not satisfactory. Sir. It was not good.
Okay. Now, Burhanuddin?
Sir, it was not satisfactory.
Okay, good. And Naushin Tarannum?
Sir, it could have been better, I think.
Not so good. And Jawatan? Afrin?
Sir, it wasn't good at all. I made a very stupid mistake.
Right. Now what to do? At least come to the class and get the bonus marks so that at the end, when I pick the best 3, at least let's say the city 4, if it is good, then best 3 I'll take. Automatically, let's say city 3 gone out, no problem. As long as your city 1, 2, and 4 is good, you get a good marks.
Sir,
And-
is there any way you could maybe consider the best 2?
No, best 3, it is the decision, and normally it is the practice. So what I'm telling you, listen carefully. I'm telling you, if you come to the class and get your bonus marks every day, that will help you to boost your quiz marks. You told you the class is, time is over now, 9:30, so we are jumping to the class. Today, what I'm going to do, I'm going to solve the problem from the previous lectures. As I told you, the complete response problem from the previous lecture. That is what going to solve first today. Now, if you look at the problem, then you can copy the question. This is not the same problem what I have shown you. And this type of problem in the final exam or in the city 3, city 4, you can expect. So you all should be very careful so that you can answer in the class test as well as in the final exam. So let us see how to solve this problem. First of all, I assume you already copied. Now let us see how to solve the problem. First of all, what you have to do, as you know, if you read the question, it is shown that there are 2 switches, S1 and S2. The switching action, you don't need to explain, you can easily understand. At time t equal to 0, switch S1 is opening and switch S1 switch S1 is opening and S2 is closing at the same time. When at time t equal to 0. So before t equal to 0, what was the condition? The condition was switch S1 was closed, S2 was open. This one was the condition before t equal to 0. And at t equal to 0, switching action change, and then after t equal to more than 0, what will happen? It is other way around. Other way around means the switch 1 will be open and switch 2 will be closed. So this is the scenario. And if this is the scenario, then what you have to do from here, you have to find the expression for IL and VL. Expression means you have to write what will be the equation, time equation for IL and VL. And also you have to sketch them. This is your complete solution. That's the way you have to solve your problem. Now, in order to solve the problem, what you have to do, the green letter, VL and IL, you have to find. And I told you last classes that you will go for finding the IL. For RL circuit problem, you find the value of IL. You find the equation for IL and you sketch it, draw it. And VL will come automatically from the IL graph. That's what I told you last few classes. So I think you all understand how to answer the question. First, you have to go for IL. Once you get the IL, then from the curve IL waveform, you can easily find the VL. You know that how VL equal to L di by dt, and from that equation, every part you can, t is less than 0, t is more than 0, you can easily find it. Now, I told you, in order to solve the problem for RL and RC problem, first thing first, you have to do. What is that I told you? Can anybody remember what the first step you have to do? First thing first, what is that?
Yes, sir. Draw two separate picture for t less than 0 and t greater than 0.
Absolutely great. It's more than 0, t is less than 0. These two picture you have to draw. So I'm going to draw separately in two pages because pages are not enough. Another one is t is more than 0. Okay, so t is less than 0 in the previous page and t is more than 0 in the second page. So if you want to draw the t is less than 0, let's say t is less than 0 means what was the switching action? T is less than 0. In the t is less than 0 case, if you look at there, S2 switch was what? S2 switch was, hey, what is S2 switch?
Sir, open.
S2 switch is this one. S2 switch was open. T is less than 0. S2 switch is open means I can simply think like this. It is not there. Open. And S1 switch is what?
Closed, sir.
Close. And S1 switch is closed means this is closed, you can think. So in this scenario, t is less than 0, you can look at the circuit diagram should be like this. This is first thing you have to do, and you can do, you get some marks. This understanding is first understanding, it must be correct. Otherwise the whole thing will be wrong. So t is less than 0, the circuit will be like this. In that case, what can we see? 6K is a floating, the whole thing on the left hand side is redundant, right? Because the circuit is open. So no current flow through this left hand circuit, only the right hand circuit will be active. Do you understand it?
Yes, sir.
Hey, rest of you, are you okay?
Yes, sir.
So what we can do, we are having on the right hand side 3 element, 6 volt source, 500 ohm millihenry, 500 millihenry inductor, and a 2K resistor. That's it. So we are going to draw that. Before drawing, we are going back to the previous stage so that we can, I think everybody understood it. Okay, now let us go for t is less than 0. We can draw now like that. On the right hand side, only this right hand side battery there, 6 ohm 6 volt battery, 2K resistor and the inductor, which is 500 millihenry. That's it. So the current IL will be here and VL will be plus minus VL. Okay, this is, forget about VL, later on we can see the VL. or target is IL first. So this is the current, this is the circuit supposed to be. If you go for t is less than 0, then the left hand side circuit gone, only the right hand side circuit will be remaining there, 6 volt connected to this. Now if we go for t is more than 0, then what will happen? After t is more than 0, S2 switch is closed or open? S2 is
Close,
what?
sir.
Closed.
Close.
After t is more than 0, S2 is closed. So we are closing the S2, and S1 switch will be what? S1
Open, sir.
switch will be open. So we can imagine there is no switch here. Open means this is open. Okay. Do you get it? In that
Yes,
case,
sir.
yeah, in that case, the right hand side circuit is redundant. Only the left hand side circuit is remaining for t is more than 0. So left hand side circuit is what? 40 volt, 4K, 3 volt, 6K, and 500 millihenry. So this is the only thing you have to draw in this case. That is the left hand side circuit you have to draw now. So in that case, I'm going back to this. I think otherwise we need it. So I think all of you understand it up to this. Okay, now let's go there. For t is more than 0. For t is more than 0 circuit, these two things you have to do correctly. Otherwise, all will go into vain. So on the left hand side, it was 40 volt. Then you have a resistor. Then you have a voltage source, I think. Then the switch was there. Switch is closed. And there is another resistance source, 6 ohm, and then is a inductor. The 2 resistor, 2 battery was there, and that's it. And it was what voltage? What is the thing of 40? This is 3 volt, I think. And what was the resistance value? 4K, right? And this was 6K, I think. And this is 500 millihenry. So this is what the values IL is flowing through the inductor current. The current flow IL. Okay, that's all about the switching was here. Switch was here, is closed. Now this is for t is more than 0, and this circuit is for t is less than 0. These are the two circuits you have to draw first. Now t is less than 0 will give you the initial condition. T is more than 0 is our point. Now if t is more than 0, this is the scenario happened. What is this thing actually? If you look, you can do it in this way, that IL, I told you already, IL you have to find like this. IL equal to IN plus IF, because complete response, the battery is applied to the RL circuit. In this case, the battery is applied to the RL circuit. In this, it means it's a complete response case. I told you already today also at the beginning, I have shown you, if the switch is closed through a battery is applied to the RL circuit, then the complete response IL equal to IN plus IF you have to write. And last class we have seen also, IN is what? E to the power, close your eye, natural response, you remember, R divided by L, T, R equivalent and L equivalent. R equivalent, L equivalent, T plus IF. IF is for T tends to infinity. IF means what? T tends to infinity. What is the current? Okay, now let's come here. IL, IF equal to what? If you want to find, if you assume T is tends to infinity, hey, if T tends to infinity, what happened to the inductor?
So short circuit.
Short circuited. For T tends to infinity, inductor goes to short circuit. If inductor is short circuited, And what will be the IL at that time? Only the 2 battery there and 2 resistor there. So IL will be what in that case? If this is short circuited, IL will be the voltage divided by the resistance. What is the voltage? Total voltage is what? In this?
43
Yeah,
volt.
so that means you can think like this: a 43 voltage and 1 resistor. What is the resistor? 4
10,
plus
sir.
4 plus 6, 10K. This is the circuit like that, IL. Right, the 2 voltages you add and 2 resistance you add, and that the current IL. So you are getting 43 divided by 10. 43K, 43 volt divided by 10K. What is the uh, value coming here? 4.3 what? What 4.3 what?
Into 10 to the power minus 3.
Oh, what is that? I should write 4.3. Then what is that? Into 10 to the minus 3 will be ampere. But if it is 4.3 only, then what is that?
Milliampere.
Right, you should tell me that thing, just milliamp. Okay, then you can write all the answer in milliampere. So this guard is 4.3 milliamp. IF will be now, this is your IF actually, this is your IF. Why IF? Because for t tends to infinity, the inductor goes to short circuit and the current at the time flowing is the IF, and that is 4.3. That's the way the IF current you have to find. Last class I told you also. IF means the inductor goes to infinity. I mean short circuit at time t tends to infinity, so you can find the current, that is your force current. Force current means for t tends to infinity, when the inductor goes to short circuited. Now, if you get it, then this is what you got the value, and IL equal to that. Now your A you have to find, or E, you have to go for E minus R by L. R equal to what? R equivalent. R equivalent means in this circuit, when you deactivate all the voltage source, just like a Thevenin resistance, how you find like that, all the source should be deactivated and find the R. So what will be the value of R? Can you tell me?
The 10K.
10K, good. R is 10K. And what will be L?
500 milliamps.
500 millihenry. So 10K, in this case, you have to write 10K means 10 to the power 3 in ohm, and this one will be, I'm just going to write here, R equivalent by L equivalent means 10K is 10 into 10 to the power 3 ohm, and this is 500 milliamp means 500 into 10 to the power minus 3. So what is the total value coming there?
The 20,000.
That's it, 20,000. So this is 20,000 T. I'm just writing it here directly, minus 20,000 T. So this is the way to write. So e to the power minus 20,000 T, and this is 4.3. That's it. This is your IL. This is your IL equation we are getting. But still, we need to find the value of what? Still the IL equation is not completed. You cannot draw it. What is the thing we don't know?
A.
A. This A is the question now. Once you get the value of A, then your IL equation is completed. And this A should come from the initial condition. As I told you, A should come from initial condition. Now, if you go, an initial condition means what? It will come from initial condition. Initial condition means for t is less than 0, what was the current IL? From there it will come. Okay. Now that initial condition is coming from t is less than 0 circuit. Before switching action, what was the condition? That is the initial condition. But t is less than 0 circuit is this one. From here, Whatever the IL you get, that is your initial condition. So let's come here. What is the IL over here for this case? T is less than 0. In the question, if you go, T is less than 0, switch S1 was closed for long time. We don't know how long. So for T is less than 0, T is less than 0, this one was the circuit for long time. That switch S1 was closed, but S2 is, this is S1 switch, was closed for long time, S2 was open long time. So the left hand side has no effect. This way actually grandfather closed the switch, and IL current was flowing through the circuit, from the circuit for long time. For long time you applied DC, your grandfather applied DC circuit, DC voltage source to the inductor for long time. So what will happen? Can anybody tell me what will be the IL current here?
3 milliampere.
How you say it?
Sir, 6 volt by 2K.
6 volt by 2K. What about the 500 millihenry?
Sir, it will be short circuited.
Right. For long time, you apply the DC source. As I told you, for DC applied to the inductor will be short circuited for long time. If the long time DC is applied for T tends to for long time, then short circuited. If short circuited, then this will be shorted, and only the 2K is the only element in the circuit, and voltage source 6 volt 2K. Any children can understand. Ohm's law can give you the 6 volt divided by 2K, and 6 volt by 2K is giving you 3 milliampere. That's what time t equal to 0, actually 3 milliampere. It's for long time, 3 milliampere is going on. Okay, I'm going to show you here. That means for long time, okay, not here, I think I'm showing you on the next page. For long time, okay, T, okay, this is T equal to 0, T is less than 0, T is more than 0. There's two action. For T is less than 0, for long time, switch was closed, and that's why the IL was, this is IL versus T. IL was 3 milliampere. So we can say it is continuously coming as 3 milliampere. So IL is 3 milliampere. Continuously, it is coming as a 3 milliampere. For T is less than 0, continuously. So ting ting ting, it's come up to, at time T equal to 0, suddenly switch S1 is open and S2 is closed. Some sort of changing of switches. So IL at time T equal to 0, after that IL will be no more 3 milliampere, it will be changing for sure. But what happened at time T equal to 0, what is the value of IL? It is 3 milliampere, right? Everybody get it?
Yes, sir.
Okay, because up to T equal to 0, it comes up to T equal to 0, 3 milliampere. So at time T equal to 0, it is 3 milliampere, we can say. So all of you try to get my point. So I can say that IL at time T equal to 0, what is the value? It is 3 milliampere also. Because T is less than 0, it was 3 milliampere up to T equal to 0. So at T equal to 0, it was also 3 milliampere. But after T0, when T is more than 0, then it is no more 3 milliampere. It will change, and it will change according to which equation? According to this equation. This will be the equation for, hey, this will be the equation for T is less than 0 or more than 0?
So more than
More
0.
than
More than 0, absolutely. T is more than 0 gives you this equation. So it will change according to that equation. Okay, now in this case, if we say at time T equal to 0, at time T equal to 0, IL equation will be what? Because this is what you know, this is T is a function of T. So at time T equal to 0, equation here, this equation here, we can write that IL0 equal to A e to the power minus 20,000 into 0 plus 4.3. Now at time t equal to 0, we can find it from here. What is the IL0 at time t equal to 0? We have found the initial condition IL0 at time t equal to 0 is equal to what?
3 milliampere.
3 million ampere.
You got the point. This 3 milliampere is at time t equal to 0. This is the initial condition. So at time t equal to 0, the IL value is 3 milliampere. You are going to put here. You all understand? Hey, what happened?
Yes, sir.
Good. Now, A you are writing, and e to the power 0 is 1 plus 4.3. Anybody can tell me A value equal to what? Hey, what happened?
Sir, minus 1.3 milliampere.
Minus 1. Everybody should understand it. This thing, if you cannot tell me from here what is the value of A, back to your younger brother, sister in the kindy street. They can straight away tell you the value. Okay. Now, if this is the scenario, then A value we got. Our target was what is the A value, and A value should come from the where? From the initial condition. Initial condition is this one. T equal to 0. The value is 3 milliampere. We already found it, and that we're giving you, that give you the value of A equal to minus 1.3. So you can easily tell me, yes sir, now I can tell the value of IL. The IL equation now you can straight away write here. IL will be equal to, ILT will be equal to, okay, minus A value equal to what? Minus, hey, what happened? Minus 1.3 e to the power minus 20,000 T plus 4.3. This is what the equation, final equation for IL after substituting the value of A equal to what? A equal to 1.3 minus 1.3. If you substitute the value over here, then the equation is coming like this. You understand it? Oh, you cannot see, and you are not telling me also. Okay, can you see now?
Yes, sir.
All of you understand the IL equation?
Yes, sir.
This is how you have to find your IL equation, minus 1.3 to the power minus 20t plus 4.3. Now, if I ask you to draw it, then how you draw? It's very simple, because this will be the equation here, ILT. So if you get the equation here, like ILT equal to, I'm writing here, okay, ILT equal to what? ILT equal to minus 1.3 to the power minus 20 minus 20,000 20,000 T plus 4.3. Now from here you can easily find out at time t equal to 0, IL0 equal to what? At time t equal to infinity, IL infinity is equal to what? Can you tell me what the value? At t equal to 0, what will be the value of IL? IL equal to minus 1.3 e to the power minus 20,000. Can you tell me? For t equal to 0, if you
3,
put,
sir.
yeah, t equal to 0, if you put, this will be, okay, 3. I think everybody should understand that is 3. And t equal to infinity, if you put t equal to infinity here, if you to put t equal to infinity, the whole
The
thing will be
4.3.
4.3. Any children can do it. Okay, so at time t equal to 0, it is 3. So it is 3. At time t equal to infinity, it is 4.3. 4.3 is somewhere above this. So assume this is 4.3. So 4.3. So your dotted line comes like that 4.3, ting, 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 like that. So at time, that means it goes to 4.3 from 0. So from 0 means 3 milliampere. So from 3 milliampere, it will go exponentially, right? Exponentially, it will go to 4.3 from 3 milliampere. So from 3 milliampere exponentially it will rise and go and mix with 4.3. This is the curve, exponentially will go and mix with 4.3. This is the way you have to draw the curve. So this will be the IL equation for the blue curve. IL equation for the blue curve will be what? Minus 1.3 e to the power minus 20,000 t plus 4.3. Do you get it now?
Yes, sir.
Hey, all of you got
Yes,
my
sir.
point? Okay. This is the way you have to draw your uh, IL curve. Now, if I ask you, go for VL, you can straight away draw the VL from this IL. And for that, what you have to go is straight away you draw it. You don't need to go and do any calculation, IL, VL, because the question said what? Question said you have to go for IL and VL and then sketch them. So you have already done the IL. Now you have to, and also sketch the IL. You've done this too. All what you have to do now for the VL. For VL, what you have to do is, uh, after getting the IL curve, you straight away get your VL from IL. So if you do that, then what you have to go for is this thing, T, and this is your T is less than 0, T is more than 0 thing. So if you go for T is less than 0, then from here you have to answer in your exam that what will be the VL. So you calculate the VL from here. VL will be what? If IL is 3 milliampere, VL will be, what is the equation? VL equal to
Sir,
what?
LDI by dt.
L di by dt. So if your L is what? Whatever 500 millihenry, you can put it, does not matter. 500 millihenry is 500 into 10 to the power minus 3. T dl ddt of IL. IL is what? Hey, IL equal to what? What is this? On the T is less than 0, IL value is what? Can you see? This is the IL value. This IL will be coming here. So what is that value?
0, sir.
Hey, no, I'm talking about IL equal to what?
3.
Oh, 3, sir.
So you put 3 here. If you put 3, after that you do the derivative and you can write the answer equal to d dt of 3 is giving you 0, right?
0. Yes,
Derivative
sir.
of a constant is 0. So you're getting 0 volt. That is the way you have to do the calculation for voltage VL. And the VL you are getting here, straight away you can say the VL is 0. So straight away T is less than 0, the inductor voltage is 0. So your VL is equal to 0 for T is less than 0. So left hand side VL you can draw up to this way. And now you go to the right hand side for T is more than 0. Again, here you have to use the same formula. You use the same formula means you write VL equal to, formula is what? L di by dt. So L is your 5,500 millihenry means 10 to the power minus 3. And d dt of L. What is L here? IL here. d dt of IL. What is IL here?
Sir, minus 1.3
Right,
e to the
absolutely. Minus 1.3 e to the power minus 20,000 t. And you have to, you can show this way, you get full marks because all need concept. So this is how you have to find the VL from here. Now, what is the VL now? If you go for from here, VL, it is 500 into 10 to the power minus 3. Then this is a constant term. You take the derivative for the constant term will be 0. You understand it? Hey, 4.3 will be 0. But the rest of the part is coming here. as a minus, I'm going to do this minus 1.3 into minus 20,000, right? It is into e to the power minus 20,000 t, and the plus 4.3 is a constant, so take the derivative of the constant will be 0. Do you got my point?
Yes, sir.
Okay, I think your brain short circuited, right? About this part you don't understand it, is it? Anybody? Do you, this is just derivative, do you understand this derivative or you don't get it? Then I'll show you in a separate page. Tell me, yeah, understand or
It's
not?
fine.
Well, no, is it okay?
Yes, sir.
Hey, rest of you? Okay,
Yes, sir.
if it's okay, fine, no problem. Good. I think then we are getting what? Can you do the calculation and tell me what is the answer coming
Sir,
here?
13,000.
Oh, great. I think you have all done. Beautiful. Equal to 13,000. So 13,000 is a millivolt. So if you multiply by 10 to the power minus 3, it will be 13 volt. So I'm writing here 13 volt. I hope that you understand what I mean. Okay, 20,000 you can write here. Okay, 20,000 T. Why I'm going to tell you in details, because next I will give you one problem and you solve it, you get a bonus point. Now listen, this is 13 e to the power minus 20 t VL you are getting. Now from here you can easily find that VL0 and VL infinity, these two values, and you can easily plot them. Can you tell me VL0 what and VL infinity what? At 13,000 means 13,000 millivolt, and I'm writing here 13 volt. I hope you all understand. You have to divide by 1,000. Okay, now what is the VL0? What is VL infinity? Anybody?
Sir, VL0
It's
13.
13.
13. And VL infinity?
0, sir.
0. Now you can easily draw the diagram. At VL0, it is 13, means it is jumping to 13. 13. Jumping to 13, and VL infinity means it is going to 0, and from here going to 0. So this will be the equation of VL. VL equal to 13 e to the power minus this equation will be for this curve. So this is your VL sketching as well as the VL equations for t is less than 0, t is more than 0. Do you all understand it? Or any question?
Sir, I have one question, sir.
Please.
Yes, sir. Last class we derive a equation for VL is equal to E naught e to the power minus R by LT. Sir, can we directly use that?
You can directly use that, uh, but in that case you have to, yeah, you have to combine them together. The 2R will be 10K and V will be 43 volt. Then you can directly
Yes.
answer, because it's equation, this is becoming exactly same. But why I am showing you this way is that when the problem is complicated, that time I think this is the way you have to, if you know this method, then any complicated problem you can solve using this method, and complicated problem you will see in future. That time you can understand that why direct method you should not, because those sort of complicated problem you need to have clear idea, clear concept, and that's what you are talking about, is memorizing the equation and substituting the value and then get it. But when the complex problem gives you, that time you will be in trouble. That time if you follow this method, then you can easily see that you can easily answer to this complex problem also using
But
this
sir, answer
concept.
will be same.
The answer will be same for this case.
But sir, if we
Yeah.
input E naught e to the power minus R by LT, then E naught will be 43. 40 plus 3 volt,
Oh,
43. Then
you are saying the answer is not same.
yes, sir.
Where is that? Oh no, I'm sorry. It cannot be. It cannot be same for this case. For this case, it will not same because of the initial condition. The initial condition that in the last class it was 0. Yes,
Yes, sir. Okay.
but in this case, initial condition is different. Oh, that is the reason why this answer will not be follow suit. But equation will be same actually. E naught equation you can write and then you can find the value from that equation and you get the same answer in that case. But because of initial condition, the value of I naught or V naught will not be same. It will be different because last class initial condition was 0 and then you can find the answer based on 0. Okay, that is why I told you that if this is the thing happened complicated, then you cannot. Let's say I give you a problem like this and tell you, like for example, I tell you like this. This problem, if I give you like this and then I tell you like this, then a switch is here and there is an inductor like this. If I say that, hey, can you solve this problem at time t equal to 0, if this is fallen here 500 millihenry, this is 6k, this is short circuit, this is what called 4k, this is 3 volt, this is uh, what is 40 volt, right? If I give you this problem at time t equal to 0, switch is closing, and find the value of IL and VL, for example, if I tell you what is the IL and VL and find it at time t equal to 0, it is closing, then you can straight away follow the formula because at time t equal to 0, IL is what? There is no current flow in this circuit. I'm talking about no other circuit. No, if only this circuit given in the exam, only this circuit. Got my point?
Yes, sir.
So in this case, what we can assume, the IL initial condition is 0 because at time t equal to 0, switch was open and there was no current flow through the 500 millihenry because the right hand side circuit is not given in the exam, only this circuit. Then you can follow the formula what last class we have done, 40 and 43, you add together this one together and then it is similar to that and then you can do, and initial condition also 0. That's why. But this time initial condition is different because of there is another circuit we have connected on the right hand side, and that's why this is becoming complicated, and that's why it cannot give you the same answer. I think you understood what is the reason, because of the
Yes, sir.
initial condition. Okay, I assume that today's class we have to go some more, otherwise you will not get it. Okay, can all of you just, this is a very, very similar problem. And I'm going to ask you to solve this problem. And just forget about all these things, what is written there. Okay, just a minute. I'm cropping the thing. There's a crop, okay. I'm just giving you this part of the question. No, nothing, forget about everything. Okay, just like this. I'm showing you like that, I'm showing you like this. Okay, that's it. Okay, now this is the problem. Can you solve it? I'm giving you 1 marks if anybody can solve it correctly. One
Okay,
bonus
sir.
point. Go first. Exactly the same thing you have to do. IL, not necessarily VL, only IL should be okay, you'll get full marks. You draw the IL and find the equation for IL and draw the IL. All of you understand one thing you have to do, this thing, this one you have to convert into voltage source and problem will be solved. And these things to voltage source, you know how to do it faster. Anybody done it? Tell me. All what you have to do is IL, find IL and sketch it. VL we can see later. First of all, IL you do 1 mark, 1 bonus mark if you can do it. I gave you the hints. The left hand side should be if anybody can do it faster, I'll give him 2 bonus marks, not 1. for this critical problem. So just do it fast. 2 bonus marks. Okay, I cannot give you 1,000 years. Okay, 5 minutes time. So 10, 15. 5 minutes, 10, 20 is over. Okay, time's up. Could you find any one of you? Yes,
Um,
Nathan, you're done.
sir, I'm not sure. Sir,
Okay,
is
if
it
not, you send it to me
Sir,
by.
I found IL, sir.
Okay, send it to me by chat box. Can you?
So me too, sir.
Both of you, just send it.
Okay, sir.
Just
okay, sir.
those who solve it, just send it. Let me see. Okay, a bit
Okay, sir.
faster. And other two guys, if you can, also you can try and send it to me. Okay, have you sent it? See the screen now, all of you.
Sir.
Can you see Jihad's solution? None of you. Can you see?
Yes, sir.
Yeah, this is the thing he had done, but he had drawn the graph from the solution. If you see, the solution is like this. Uh, t is more than 0, t is less than 0. T is less than 0, this one is the circuit. That time the circuit was closed, with this switch was closed and switch 1 was closed, and 6 volt supply was giving to the 680 millihenry uh, millihenry inductor, and through the 1K, and that gives the initial condition, which is he found minus 6 milliampere. This is the critical issue, because the battery positive terminal this time, the 6 volt battery in the problem, it is other way around. Can you see in the previous problem, 6 volt battery terminal was upside positive, downside negative, but this time it is other way around. That's why the IL current is opposite this time. Okay? That 6 volt battery is supplying the current to IL should be negative in that case, because the direction of the battery is opposite. This is the most critical thing, and this is the important thing here. Most of you can make a mistake. So since it is minus 6 ampere milliampere, that's why you can see t is less than 0 gives him minus 6 milliampere here. 6 minus 6 milliampere. At time t equal to 0, from minus 6, it jumps up, and that one more than t is more than 0 is the thing. T is more than 0, what? This switch is open, this is gone, only the left hand side circuit is activated, and this voltage source comes from the current source. As I told you, the current source should be converted to voltage source. So he got the current source conversion is 2.64. Is it, Jihad? 2.64. Jihad, can you see?
So
Yes, sir. Yes, sir.
26.4.
What? Okay, 264. What are you written there?
It's 26.4.
26.
26.4, sir.
Oh, Jihad, you don't get it what you have written. How come we understand?
No, sir. My
So
mic was
you
muted.
should tell me 26.4 volt, and the resistance is what? 2.2.
Yes, sir.
The 2.2 and 2 point, and this 8.2 is giving you
8.2.
10.4. That's why he had written 10.4 here, and this is 6.2, and this is 26.4 volt. And from here you can write the equation like this, and A you find, and from the initial condition at time t equal to 0, the initial condition is minus 6.
Minus 6.
Yeah, well, last time it was 4.3 milliampere. I'm sorry, 3 milliampere. This time it is minus 6 milliampere. at time t equal to 0. And from there, he found the value of a equal to minus 8.54. Okay, good. 8.54. So he got the equation, IL equation is like that. And he got the time constant. What is that time constant he got? Where is the time constant calculation? Here, R equivalent by L equivalent. He found this calculation from R by L. Okay, I think everybody know that. So it is a very simple thing. On equation IL equal to this, from here, if you put t equal to 0, t equal to infinity, you get t equal to 0 means you're getting minus 6 volt milliampere, and t equal to infinity you got minus plus 2.54, and that's what he had done. T equal to minus 6, t equal to 0, and t equal to infinity gives you 2.54, and jumping to 2.54. Last time it was 4.3, so it is 1.3, and now it is I'm sorry, 4.3, and now it is 2.54. So it's jumped to 4. The absolutely correct answer this one, but I have to write the equation for this line and this line. And if you want to do the voltage, you can easily do the voltage. Jihad, by this time did you do it? Not yet.
Yes, sir. I got the equation and I'm drawing. Yes, sir. It was.
Okay, voltage
Can I say?
is no. I'm just asking. If it is less than 0, what will be your voltage?
Less than 0, 0, sir.
Yeah,
Voltage.
voltage will be 0 because it's a constant. And more than 0, at what value it will be jumping to from 0 to?
So 0 to 88.81.
88.81. Good. 88.81, and for t tends to infinity, it goes to 0. So it is same like what we have got last time. In our previous problem, the voltage was jumping to 13, and from 13 volt, it goes to 0. Now in Jihad's case here, it is 88.8 volt to 0. So that's correct answer. And all of you, I'm just asking, do you all understand it, how to solve this problem? Let's see that. Six, okay, I'm giving it to you, Jawatan. If you
Yes, sir.
know the voltage waveform, you do the voltage waveform for me, and then you get full marks.
Okay, sir.
Do it and send it to me.
Okay, sir.
And you have written it is 2.5, but it should be 2.65 or something like that, right?
No, 2.54.
Or 2.54, right? Sorry. So she didn't write 4. Okay, and okay, you have shown me other way around.
Sorry, sir.
Upside down.
Sorry, sir. I was in a hurry, so.
Okay, no problem. You can just carry on. It is very hard to understand because of absolutely
Download it and flip it.
all of you can see, right? All of you can see.
Yeah.
Okay, how?
It's 2.54 minus 8.54 exponential to the power minus t divided by 65.39.
Okay, can you show me graph for the voltage? Send
Yes,
it
sir.
faster.
Okay, sir.
Okay, then I can see that. All right, no problem. Now let's come back to the point. Once you send it to me, let me know. Let us jump to the RC circuit. Okay, now can you see the screen?
No, sir.
Okay, you can see now, right?
Yes, sir. No.
All right, now the RC circuit, which is very similar to the RL circuit, and in this case, we'll see the first thing we are going to see today is the natural response. Natural response, if you see the natural response, uh, it is the same way what we have done last time, that there was a capacitor here and a resistor here, and for example a resistor is going to connect it to a source like this. and this is your R, and this is your C. And what happened here now, at time t equal to 0, the switch is going to be open from here. Before that, the current was flowing through this in this direction. So one current was flowing through the capacitor, another current was flowing through the resistor. And because of that, what happened? A voltage was developed here. And that voltage we can say as VC voltage. So VC voltage is here as plus and minus, like that. We are going to give this explanation in this way. Before t is equal to 0, that means t less than 0, it was closed. And if it is closed, then what happened? The current from the battery is flowing through the circuit in this way. The current is dividing into two, IC and IR. And the true current was flowing through the resistor and the capacitor. And what happened? When the IC current is flowing through the capacitor, then the capacitor voltage, as I told you, like the water flow into the bucket, the water is accumulating, the pressure of the bucket is increasing, the water pressure. Exactly the same way you should think like this, that when the charge is accumulating in the capacitor due to the current flow, I see the charge is accumulating into the capacitor, and because of the charge Q, V is proportional. I told you, the more the charge accumulating, the voltage across the capacitor is increasing. Remember, I told you like this. Hey, what happened? Can you listen to me what I'm telling? Hello?
Yes, sir.
Yes, sir.
Do you have any question up to this? You please let me know. Main thing here, I want to say the cause and effect. Due to the battery, you connect to the RC circuit, which are in parallel, then the voltage across the capacitor is increasing. Why? Because of what I told you last time, right? The current flow through the capacitor, charge is accumulating. Because of the accumulation of the charge, the voltage of the capacitor increasing, like that. Now you understand? Yes?
Yes, sir.
Now you look carefully. With the voltage developed in the capacitor at time t equal to 0, if someone open the switch, at time t equal to 0, the switch is open. When the switch is open, then the capacitor which accumulated the charge will discharge the, all the charge will be discharged from the capacitor through the capacitor current, and the voltage of the capacitor will be decreasing slowly. This is the scenario. And that voltage VC will decrease slowly to 0. Again, the same way, I square R loss, and through that loss, it will be decreasing. So in this scenario, the voltage of VC across the capacitor, when the switch is taken off, then it will be a simply free running RC circuit, and the voltage VC in this case will be decreasing slowly to 0. It will be, again, you can see, exponentially decrease the voltage. What we have seen in the last RL circuit, free running RL circuit, it was decreasing, IL was decreasing exponentially. In this case, the VC will be decreasing exponentially. And that equation will come from here, this point. If you apply the KCL, that IR and IC will be adding together, because both are outgoing, you can assume IC and IR. So you can write IC is dVC by dt and IR is VC by R. VC is the voltage across the resistor as well as the capacitor because they are in parallel. So if you go with that, then the VC by VC will be minus 1 by RC dt. Now, if you go with that integration, RC is a constant, so you are getting the integration with this, and you are getting here ln of VC and your G to T and equal to minus 1 by RC. Anybody cannot understand anywhere, please stop me and tell me. Okay, this is from here to here 0 to T. RC is coming from here. Now, again, you have to go with the ln VC to T. So your ln VC to T here, you can go with the 0 to T and equal to minus 1 by RC, and T will be 0 to T. It's T minus 0 you are going to get. So you are getting here ln VC T minus ln VC 0, and this is giving you minus T by RC. And what happened now? Ln VC by, just like last time, you got VC 0 and equal to minus T by RC. See. So if you go for VC by T by VC 0, you are getting here minus e to the power minus T by RC. This is what you are getting here, and VCT will be equal to VC 0 and e to the power minus T by RC. Now what is VC 0? If you come to the equation here, when time t equal to 0, when the switch is open, at that time the capacitor voltage, at that moment the capacitor voltage can be, because when t is going on, the charge is accumulating, capacitor voltage is developing. But at that moment, if somebody opened the switch, at the time when you open the switch, at that moment there should have some voltage across the capacitor terminal, and that will be the initial voltage, and we can assume it is V naught. Like last time we consider I naught, so we can assume this is V naught. So the VC0 VCT will be equal to V naught e to the power minus E by RC. So this is your voltage equation for the capacitor, which is very similar. Last time I'm just writing here, for the inductor we have the equation like this. Can you remember what was the equation? I naught. Anybody can tell me? For the inductor current.
Yes, sir. E to the power minus R by LT.
So many times you have solved the problem. Okay, this is the inductor and current equation. In case of capacitor, it is not current, it is the voltage, because voltage is increasing and voltage is decreasing. Voltage is decreasing in this case, so the resistance I square R loss. The current will be coming out from the capacitor, and the capacitor current will be flowing, and then so the I square R, it will be a decrease, but the current will be flowing in the opposite direction. It will be seen later, we'll talk about it. Now, this is what the equation we got for the capacitor voltage. Remember, for RL circuit, it is the inductor current. For capacitor circuit, RC circuit, it is the capacitor voltage, not capacitor current. Capacitor current, you can find it from the equation. From the equation, capacitor current will be coming like this. What is the capacitor current? If I say IC equal to what? If you want, hey, what is that? IC equal to, remember, dVC by dt is the equation, right? Capacitor current equation.
Yes, sir.
So your VC you substitute here, and then you can get it. What is that thing coming? You can easily find it from there, and you can easily, what is that? V naught, then 1 by RC, right? Minus 1 by RC, and 1 by RC into e to the power minus t by RC. That's what you are getting here. And if you simplify, RC coming there, C and R, so CC cancel out. So you are getting what? V naught by R. V naught by R, and minus sign will be coming, and e to the power minus t by RC. So that is your IC you can get. This will be the IC equation you should get from the VC equation. So all the time, whenever you are going to ask to find the VC and IC, you first find the VC, and then from the graph of VC, you have to find the IC. Like in inductor case, you have done RL case. You first find IL, and from the IL, you found the VL by using the VL equal to L di by dt. In that way, in case of RC circuit, you find the VC and draw the graph, and from there you find the IC. Throw the equation IC equal to C dVC by dt. Last time you found the VL from L di by dt. Now in case of RC circuit, you find the other way around. Actually, everything is other way around. You have to find the IC from the equation C dVC by dt. Jawatan, have you sent your VL L di by dt yet?
Yes, sir.
Or you discuss with Jia if the answer is correct or not?
No, sir.
Okay, good. Okay, no
I
problem.
don't talk.
So, like Jawatan had done the thing actually, she got the IL, and now she is going to submit the VL. How she got VL? VL equal to L di by dt. Then, in case of RC, the other way around, VC you have to find, and I hope that you understand it. Now we are going to draw the circuit for this one. Let's see. VC equal to, we have found here V naught e to the power minus T by RC. I'm not going to show too much because you already know. So what is the VC 0? Time t equal to 0, it is V naught. And what is VC infinity? Hey, what is that? It is 0, right? Jia, you get my point, what I'm doing?
Yes, sir.
Okay, good. So now I hope all of you understood that at time t equal to 0, it is V naught. At t infinity, it is 0. So exponentially, it is dying. Exactly the same thing what happened. So VC in this case will be equal to, the equation is equal to V2 of e to the power minus T by RC. So this is what the voltage. And if I go for current equation, as I show you, current equation was derived from the thing is IC equal to minus V naught by R e to the power minus T by RC. So that is your current equation. So your current equation, you can go ahead like this. If you go with that current equation P, okay, then what is the current equation you get from here? This is IC, and the IC equation is coming from here. As I told you, you have to find it from here. IC equal to, already we found. I'm just going to show once again, but I'm not going to show you details. If you do it in this way, you get minus V naught by R e to the power minus T by RC. As in the last page, I have already shown you here. This one I'm talking about. So this graph, if you get this graph, and then you can find IC 0, IC infinity. And can you tell me, Jihad, what is this? What is the value of IC 0 and IC infinity gives you from this equation?
Yes, sir. IC0 minus V0 by R.
Minus V0 by R. Good. And Jawatan, can you tell me what will be the IC infinity? Hey, you two guys are going to get the
Yes,
bonus
sir.
point. So you have to respond. Yeah, what is that? IC infinity will be what, Jawatan? From this equation, IC equation, this is IC equation. That means you are going to put the
0.
value of 0, good. T equal to infinity means it will be 0. So from minus V naught to 0, minus V naught is here, which is minus V naught by R. Jawatan, do you understand this thing?
Yes, sir.
Yeah, it's the last page. Actually, we have done it from here. This is from here. Okay, good. So it is from this, from minus at time t equal to 0, it is V naught, but it's a minus. That's why it's down and goes to 0 and goes to 0. So this is the equation of this thing. So what is the equation for this? Okay, Jonathan, just tell me what is the equation of this thing? IC equal to what? That's it.
Sir, IC,
Hmm.
sir, IC will be IC not, sorry,
IC not means what? Over here.
it's
Look at
V
the
naught
equation.
by R.
Right, V naught. But there is a minus sign there. Do you know that?
Minus V naught by R, yes, sir.
Right, V naught by R, e to the
E to
power
the
minus.
power minus D by RC.
Okay, good. And here, remember, this RC is your time constant. You know that, remember last time constant, you draw the tangent, intersect here tau, then 2 tau, 3 tau, like that we have done for the last time for the RL circuit. So it is the same thing happening here, 5 tau, like that. And this tau equal to RC in this case. If you do the same thing, same way I have shown you in the RL circuit, you can see this time the tau value will come R equal to RC. I'm not going to show you here. So it is the same thing, the same percentage of decay you can see. That's why I told you in RC circuit, I'm not going to show it. You can do it by yourself. Only I think tell you in the same way if you find the time constant. Last time time constant was tau for the inductor RL circuit. Jiyad, can you remember time constant was what last time for the RL circuit?
Yes, sir. L by R, sir.
L by R. And this time the time constant for RC circuit will be tau equal to RC. L by R we have derived in the last time for RL circuit. Exactly the same way here. If you derive, you can see the time constant will be tau equal to RC. So we are not going to waste time here. I hope that all of you understand it so far today. So example 1, all of you can just draw it. Okay, the question will be like a resistor can be here, simple, and a switch can be here, and a voltage source can be here, and a resistor here, and a capacitor here. Okay. 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 Now you have to find, let's say 2 ohm resistor. This is your 4 ohm resistor, and this can be a capacitor of 10 microfarad. Okay. Now this can be a voltage plus minus 9 volt. Okay. Now all of it you have to do is you have to find the value of find the equation for the capacitor voltage, which is VCT, and plot it. At time t equal to 0, the switching action is at time t equal to 0, switch is going to be open. So what will be the VC nature? And find VC and IC and sketch them. This is a problem on natural response. Natural response. Remember, no fixed response. Because why natural response? If you look at the circuit switching action, at time t equal to 0, the battery is taken out. If the battery is taken away, then the circuit, remaining circuit is nothing but a RC circuit. Resistance and capacitance are there. So it will be a free running RC circuit, and you can easily apply the equation and can find the solution. Now you look, all what you have to do, as today you have also seen, and Jiyad also told, sir, first thing first we have to do is we have to draw the 2 circuit, and you must get some marks for that also. 2 circuit, 1 circuit is, Jiyad, what is that? T is
Less than 0 and
less
on
than
T
0,
is
T is
greater
more
than
than 0. That's your first job, and then you can start up. So if you go for T is less than 0, the switch was closed. That means the battery was connected with that, and then the circuit will be looked like what? The circuit should be looked like this, and this one here, and the switch was closed. So the closing the switch, and then you have the 9-volt battery plus minus 9-volt battery is connected, and the resistor here, and the capacitor is here. So this is what the switch looked like, the circuit looked like. And for t is more than 0, if you go, t is more than 0, so switch is open. If the switch is open, then it is having a free running RC circuit. If the switch is open, then it is look like this, that the battery is taken off. Then what? You are getting a simple RC circuit, 2 ohm, 4 ohm series and capacitor in parallel. So you can easily draw this circuit like this. So you can just get a 2 ohm, 6 ohm resistor, and the capacitor is there, and here is the resistor. Okay, so you can get it here as a 2 ohm resistor and 4 ohm resistor and 10 microfarad and 10 microfarad capacitor, and it is your VC. What you have to find, VC plus minus, which is a very important thing for you to find here. And this is your 2 ohm, this is your 4 ohm, and this is a 10 microfarad capacitor, and your VC is here also like this. Now it is a 9-volt battery. Now these two things are there. T is more than 0 is your target, so, and you have to find the VC. Now it is a free running RC circuit, and VC for free running RC circuit is what? Look at this. This is just like a RC circuit where R is this combination together. 2 and 4 is giving you 6 R, and C is 10 microfarad. And free running RC circuit, just now I show you, this is the free running RC circuit, right? Which is R and C. In our case, free running RC circuit 4 and 2 and 4 is a 6 ohm, and this is 10 microfarad. It's exactly the same. So you can easily close your eye and use this equation, which is VC equal to V naught e to the power minus T by RC, full stop. So since it is a free running RC circuit, so you can write here VC equal to minus T by RC. RC means again R equivalent, C equivalent, that together all the values. So you can write V naught e to the power minus T by, Jonathan, can you tell me R equivalent equal to what? C equivalent equal to what? R equivalent is what?
R is 6.
Okay, just finish it and then go. C equivalent is what? You be ready, 2 of you at least, Jia than you.
Yes, sir. 10 into 10 to the power
So
minus 3.
10 into 10 to the power minus
6. Good. Jonathan, forget about your other class. I'm giving you the 2 marks. This is important to you. So be careful about it, and then you go. Now, this is what is the V naught you are going to get here, e to the power minus. Can you tell me, both of you, 1 by 6 into 10 to the power minus 6, ultimately what you are getting?
So 6 into 10 to the power 6.
No, 1 by 6. You have a
6 into
calculator.
10 to the power minus 5, sir.
No, I'm talking about into something into T I'm writing. What will be this? 1 by 6 into the, that means 10 to the power 6 by 6.
So 1.6 into 10 to the power 6. So
1.6. 1 by 6 is 1.6.
No, sir. 6
sorry,
into
0.16.
No, not 6 into. I'm talking about 1 by 6 by 10 to the power 6 equal to what? You got my point.
Yes, sir. Yes, sir. Sorry.
I'm sorry. I'm sorry. 1 by 6. 10
Yes,
to the
sir.
power
It's
6 by 6 is the word. I'm talking like that.
Sir, 1.6 into 10 to the power 5.
5. Okay. That's what I'm talking. Okay. So, Jia, this is okay. Is it correct? 1.6 into 10 to the power 5. Is it correct? Into T. That means 10 by 6 into 10 to the power 5. Is it like that?
yes, sir. It's correct, sir.
10 to the power. That's okay. So this is the time constant, which is very important. That's time constant you have to calculate correctly. This is time constant through which it will be decaying. Okay, so e to the power minus T V naught. All what you need to find the V naught value and then go. What is the V naught? V naught will come from the initial condition. This is initial condition. Initial condition comes from here, the V naught.
Yes, sir.
So VC0 gives you the V naught, and that V naught equal to what? From this circuit you have to calculate. Let's come back to this circuit. This is very important. From this circuit, what will be the V naught? Look at it. In this circuit, long time, T is less than 0, long time, the 9-volt battery is connected to the capacitor. So capacitor will be what? Short circuit or open circuit?
Open circuit, sir.
I and
Open
rest of
circuit,
you,
sir.
yeah. 1 by omega c. Omega c means I told you like that 2 pi f c, and 1 by f is 0 because of zero frequency. So 0 means infinity ohm. So it is open circuit. So open circuit means it is open circuit voltage. So VC will be open circuit voltage. So what is that? Open circuit means these 2 points should be open. Jawatan Afnan, what will be the open circuit voltage? That means this circuit is open. There is no VC here.
Yes,
Assume.
sir.
So this is AB. Now what will be the VAB? Tell me.
To 9 volts.
Beautiful. 9 volt. Open circuit voltage is 9 volt. I think that's good. Excellent. So your V naught will be open circuit voltage. So long time the V naught is open circuit voltage. This is your V naught. Actually, this is 9 volt you are getting here continuously because of that's good. And now you substitute this value over here as a 9 volt. So the equation is coming here 9 e to the power minus 1.67 and 10 to the power minus 5 10 to the 5 t. So this is what your equation for VC. I hope that all of you understand it now. And if you want to plot it, can you tell me t equal to 0, t is less than 0, t is more than 0? Jonathan, tell me first. T is less than 0. What should be the voltage here? T is less
0.
than. Oh no.
Sorry, sir. Sorry. 9, sir. 9.
9 volt.
9
Don't
volts.
make a
And
mistake
then
like
it will
that.
exponentially decrease. I'm sorry.
Okay, good. So it is 9 volt here. Excellent. Good. V0 continuously open circuit voltage is coming. And for t is more than 0, this is the equation. For t is more than 0, this is the equation. And this is the equation for t is less than 0. T is less than 0 is that. That's 9 volt you got. Okay, can you tell me now what will be the thing here?
Yes, sir. The equation is 9.
No, tell me
Yes,
first.
sir. T is equal to 0, it will be 9, and T is equal to infinity,
It
0.
will be 0.
Good.
So it will
This is
exponentially decrease.
9 and it is exponentially decrease. Good. So exponentially decrease it to 0. So Jawatan, last question. What is the equation for this line?
Sir, 9e to the power minus 1.67 into 10 to the power 5.
10 to the power 5 t. T, don't miss the t. Okay, this is what the VC equation, a VC curve you got. And last question to Jiyad, and
Yes,
that's
sir.
it. If I ask you the current waveform, what to do? IC. You don't need to go to the circuit. From the VC waveform, you can find the current waveform IC. Now, how you do? Go fast and then go. Yeah, Jawatan,
Yes, sir.
you can go now. And on behalf of you, I think what do you call the Jiyad can tell me your name,
Yes, sir.
and I'll give you the point. No problem. Now you tell me, Jiyad,
Yes, sir.
how
Sir.
to find IC? IC equal to what?
Sir, less than 0 is equal to 0, sir.
Yeah, how you got that one? We need to know. So formula.
Yes, sir. It is IC is equal to C dVi by dt.
Beautiful.
dVc by dt.
by
sorry,
dt. dVc by dt means it is 0 because Vc is constant 9. So it is 0. Excellent. Now, whatever the next one. So IC equal to 0. Next IC after t is more than 0. What is the IC? This is t is more than 0, right? So
Yes, sir.
can you tell me? I'm going to take it
Yes,
off.
sir.
Yeah, tell me. I'm writing
10
here.
into 10 to the power minus 6.
IC equal to dVc c into
Yes, sir.
dVc by dt. Okay, and what is the c? Is a 10 to the power minus 6. 10 into 10 to the power minus 6 into
Minus 6.
if you take the direct derivative of this thing, what is that?
Yes, sir.
This is coming
Into
here.
9. 9.
Into 9 into go minus
Into 9 into minus 1.67
1.6
into 10 to the power 5
5. Good.
into e to the power minus
Minus 1.6 e to the power 1.6 into 10 to the power minus
5.
10 to the power minus 10 to the 5, right?
10 to the power 5, sir. Yes.
Okay, t. Okay, that's what your IC equation. And if we put IC equal to 0, what is the value coming? From this equation, if you put IC equal to 0, Okay, did you do the calculation? All calculation, how much you got together altogether?
No, sir. I'm doing it, sir.
Can you just tell me what is the total value coming if you multiply?
Minus 1.
All of you can help Jihad as well and find the within the red box. If you do the calculation, what is the value you get?
Yes, sir. It is minus 15.03.
Okay, you got the equation. In that case, you get the equation for that, the total equation. Can you tell me the final equation you get what then?
Yes,
IC
minus
equal to, IC equal to minus
15.03
15.03 into 10 to the power
into e to the power
e to the power. Okay, minus
1.67 into 10 to the power 5
10 to the
t.
power minus 5. 10 to the 5
Sir,
t.
5.
Yeah,
Yes.
10 to the 5 t. So I see 0, I see infinity. That's it. But come on,
Yes, sir.
I see
Sir,
0
I see
equal to
0
what?
minus 15.03, sir.
Okay, minus 15. I'm just assuming, and then this one infinity.
0, sir.
0. So you're jumping down from here, you're jumping down to minus, this is minus 15, and you're jumping down here and then go back to 0 like this. This is the way you should go, right?
Yes, sir.
Okay, it's going to 0. Now, I'm asking one question to Akib or Nausin Taramnum. Any of you can give me the answer. What is the equation for this line?
Sir, minus 15 e to the power minus 1.67 into 10 to the power 5t.
Beauty. Excellent. Good. I think that's the end of today's class. All of you understand very well. I assume everybody understood it. And next class, we are going to jump to the complete solution for RC circuit, and we will solve the problem on that. And then I will discuss about some of the problems from 7 final exam question paper. You please, all of you will try. And if you have any question regarding any of the problems from the 7 sets of problem final exam question paper, you please discuss with me, because those are the sample problems you have to face in the final exam as well as CT4. So very, very important to solve for everybody all the 7 sets of question paper. I think that should be great. Thank you very much for staying up to now, and I will give value for coming to the class. No doubt, definitely. Okay, I think now the class officially over, and if you want to go, you can go, but Jia, you stay back, and
Yes,
I
sir.
will give you the marks for the class. Okay, just 1 minute. Hopefully we'll go for it. Just 1 minute. Okay. Now